Integration of SpaceX's Starship in 2024, 5 critical milestones and $3.2 billion funding allocation for interplanetary missions. Overview. In 2024, SpaceX's ambitious Starship program is poised to revolutionize space exploration, particularly with a significant funding allocation of $3.2 billion dedicated to interplanetary missions. This investment will support critical milestones that will enhance capabilities for lunar and Martian exploration, as well as bolster satellite deployment and foster international collaboration in space technologies. Key milestones for Starship integration. 1. First crewed flight. SpaceX aims to conduct the first crewed mission of Starship, allowing astronauts to assess and experience the craft's capabilities firsthand. This milestone is critical for gathering data on human factors in space travel, which will inform future missions. The crewed flight is anticipated to take place in the latter half of 2024, paving the way for subsequent lunar and Martian expeditions. 2. Lunar missions. Starship's role in NASA's Artemis program will be pivotal for lunar exploration. The spacecraft will transport astronauts to the Moon's surface, particularly under the Gateway Initiative, which aims to establish a sustainable human presence on the Moon. The integration of Starship into these missions represents a significant step in lunar exploration, with missions planned for late 2024 to early 2025. 3. Mars preparations. The design and testing phases of Starship are specifically tailored for long-duration missions to Mars. This includes the development of life support systems, fuel production technologies, and sustainable practices essential for successful interplanetary travel. Preparations for Mars missions are expected to ramp up in 2024, with a focus on achieving reusability and reducing costs associated with deep space travel. 4. Satellite deployment. Starship is set to enhance SpaceX's capabilities in deploying large satellite constellations, including those for global internet access through the Starlink program. The craft's ability to carry heavy payloads into orbit will allow for more efficient launches, potentially increasing the speed of constellation deployment and improving global communication infrastructure. 5. Research and development. Continuous research and development efforts will ensure that Starship meets the demanding requirements of space travel. This includes advancements in safety protocols, environmental considerations, and technological innovations that will enhance the reliability and efficiency of space missions. Investments in R&D are critical to addressing engineering challenges and ensuring the safety of crewed missions. Funding allocation and strategic goals. The $3.2 billion funding allocation is not only aimed at fulfilling the key milestones outlined above, but also at fostering collaboration with international space agencies. Notably, the Canadian Space Agency (CSA) is a key partner in lunar exploration efforts. This funding will support joint initiatives, including the development of technologies and systems that facilitate sustainable exploration on the Moon and beyond. Themes across sources. Sustainability and reusability. A shared focus on environmentally responsible exploration underlines the need for sustainable practices in space technology development. This includes efforts to minimize space debris and maximize the use of in situ resources on celestial bodies. International collaboration. Reports frequently emphasize the importance of partnerships with international agencies and private sector entities, showcasing a unified approach to advancing space exploration. Differences in perspectives. Technical versus strategic focus. Some discussions center on the technical specifications and challenges associated with Starship, while others highlight the strategic implications of interplanetary missions for national and commercial interests. This divergence reflects the multifaceted nature of space exploration, which encompasses engineering policy and economic considerations. Timeline variability. There are variations in perspectives regarding the timeline for achieving specific milestones, with some sources maintaining more optimistic projections than others. This reflects the inherent uncertainties associated with complex aerospace projects. Timeline of events. 2023, continued testing of Starship prototypes with successful uncrewed missions serving as a foundation for upcoming crewed flights. April 2023, announcements regarding international collaboration including CSA astronaut Jeremy Hansen's participation in the Artemis II mission highlight the importance of cooperative efforts in space exploration. Late 2023, progress on the Lunar Exploration Accelerator program sets the stage for upcoming lunar missions emphasizing collaborative technology development and operational planning. 2024, expected crewed flights of Starship and potential deployments for lunar missions marking a significant advancement in human spaceflight capabilities. Conclusion. The integration of SpaceX's Starship in 2024 is set to mark a transformative period in space exploration. With critical milestones focused on crewed flights, lunar missions, Mars preparations, satellite deployment, and robust research and development. The $3.2 billion funding allocation will play a pivotal role in shaping the future of interplanetary missions. As SpaceX collaborates with international partners like the Canadian Space Agency, the vision for sustainable and responsible exploration of the Moon and Mars becomes increasingly attainable, positioning humanity for a new era of discovery in space. Counterintuitive information from the content. 1. Funding allocation versus technological advancement. While a significant investment of $3.2 billion is outlined for the development and integration of SpaceX's Starship, one might expect this funding to be primarily directed towards advanced technology development. However, a substantial portion of these funds is actually earmarked for collaboration with international space agencies such as the Canadian Space Agency (CSA). This suggests that SpaceX's approach is not solely focused on proprietary technological advancement but also on building partnerships, which could be seen as counterintuitive in a highly competitive field like space exploration. 2. Focus on sustainability. The mention of sustainability and reusability as core themes in the Starship program may contrast with traditional views of space exploration, which often emphasize sheer technological capabilities and advancements. The emphasis on environmentally responsible exploration indicates a shift in priorities that goes against the grain of the old-school approach to space endeavors, which historically prioritized aggressive technological race without considering ecological impacts. 3. International collaboration versus national interests. The integration of international partnerships such as with the CSA complicates the narrative that space exploration is strictly about national pride and competitive advantage. Instead, it highlights a more collaborative global approach to exploration, which could be surprising given the historical context of space race dynamics, where competition was the primary driver. For budget cuts amid increasing activities, the Canadian Space Agency's report indicates a variance between planned and actual spending, with a notable decrease in actual spending despite the increase in activities related to space missions and international collaboration. This counterintuitive dynamic suggests that organizations can engage in more extensive programming without a proportional increase in budget, which challenges the assumption that funding levels are directly correlated to mission scope and activity levels. 5. Human resources growth amid budget constraints. The CSA has experienced a growth in full-time equivalents FTEs despite a reported decrease in planned budgets for upcoming years. This situation raises questions about resource allocation strategies and the ability of organizations to sustain and expand their workforce even when financial constraints are apparent. It contradicts the conventional wisdom that budget cuts lead to workforce reductions. 6. Public perception of space exploration. The report emphasizes the tangible benefits of space exploration for Canadians, suggesting that space missions improve daily life through technology transfer and innovation. This may counter the public perception that space exploration is a luxury or a distraction from pressing societal issues. The connection made between space activities and practical benefits for everyday life challenges the narrative that space endeavors are disconnected from terrestrial concerns. 7. Investment in Indigenous businesses. The Canadian Space Agency's target for contracting with Indigenous businesses is set at 5%, yet the actual percentage achieved was below that target at 3.83%. This outcome might appear counterintuitive in the context of increasing awareness and advocacy for indigenous rights and participation in economic opportunities. It highlights the challenges of integrating indigenous businesses into specialized sectors like space, where barriers to entry can be significant. 8. Technological challenges versus strategic goals. Reports suggest a divergence in focus between technical specifications and strategic implications of interplanetary missions. Some sources emphasize the engineering hurdles associated with Starship, while others highlight the broader strategic importance of these missions for national and commercial interests. This dual focus could be seen as counterintuitive, as one might expect a singular narrative focused on either the technical or strategic aspects rather than an intersection of both. 9. Impact of external factors on space programs. The Canadian Space Agency's report alludes to external challenges such as cybersecurity and talent shortages affecting its operations and strategic direction. This acknowledgement of vulnerabilities may seem counterintuitive, as space agencies often project an image of robust capability and resilience. The recognition of these risks points to a more nuanced understanding of the operational landscape in which space agencies function. 10. Global economic impact of space exploration. The CSA's report claims that investments in space not only advance technological breakthroughs but also stimulate economic growth. This assertion may seem counterintuitive, as the immediate costs of space missions can appear exorbitant. However, the long-term economic benefits, including job creation and technological innovation that spills over into the civilian sector, challenge the notion that space exploration is merely an expensive endeavor with little return on investment. These insights underscore not only the complexities of the space exploration landscape but also the evolving narratives and priorities that may not align with traditional expectations or assumptions. Important content overlooked in the report. 1. Significance of international collaboration. The report emphasizes collaboration with international space agencies, particularly the Canadian Space Agency (CSA) and its contributions to the Gateway lunar program. While many readers may focus solely on SpaceX's technological advancements, the importance of international partnerships is critical. These collaborations not only enhance the capabilities of SpaceX's missions but also ensure a broader support network for global space exploration. The unification of resources and knowledge sharing can lead to more effective problem solving and innovation in technologies essential for interplanetary missions. 2. Funding implications for economic growth. The $3.2 billion funding allocation is not just a financial statistic but a driver for economic growth. The report notes that this investment will stimulate the Canadian economy, particularly in the space sector. However, the wider implications for job creation in STEM fields, as well as the potential for Canadian businesses to engage in space-related contracts, are often understated. The focus on funding should also consider how these financial resources can lead to technological advancements that benefit terrestrial industries, such as telecommunications and environmental monitoring. 3. Sustainability and environmental considerations. The report touches on the importance of sustainability and reusability in space missions, which is a significant trend in modern aerospace endeavors. However, the report does not delve deeply into how these sustainability initiatives can reshape the future of space exploration. As climate change becomes an ever-pressing issue, the methods developed for sustainable space travel could also be applicable to Earth-based challenges. The significance of these innovations extends beyond space exploration, potentially providing solutions to environmental issues on Earth. 4. The human factor in space missions. The mention of the first crewed flight of Starship is significant. Yet the report could benefit from a deeper exploration of the human elements involved in these missions. The psychological and physiological challenges faced by astronauts during long-duration spaceflights are critical for mission success. Understanding and addressing these human factors can lead to improved training programs and technology that ensure the safety and well-being of astronauts, which is often overshadowed by the focus on technical specifications and milestones. 5. Technological innovation beyond space exploration. The advancements realized through the Starship program and related projects will have implications beyond space travel. Innovations in materials, propulsion systems, and robotics can lead to breakthroughs in various industries on Earth. The report could emphasize the potential for technology transfer, which can inspire investment in research and development sectors that may not be directly linked to space exploration but can benefit from these advancements. 6. Impact on global space policy. The strategic implications of SpaceX's Starship missions on global space policy are significant yet often overlooked. As SpaceX moves towards interplanetary exploration, it will inevitably shape discussions surrounding space governance, international law, and the ethical dimensions of space colonization. The report could highlight how successful missions could influence future treaties, regulations, and collaborations at the international level. 7. Public engagement and inspiration. The report is largely technical and financial, potentially missing an opportunity to engage the public's imagination regarding space exploration. Emphasizing the inspirational aspect of missions, particularly the involvement of astronauts in public engagement initiatives, could resonate with a broader audience. Highlighting how these missions can inspire future generations to pursue careers in STEM and space-related fields is crucial for sustaining interest and support for space exploration. 8. The role of indigenous participation. The report mentions contracts awarded to indigenous businesses but does not fully explore the significance of this engagement. Indigenous participation in space initiatives can foster inclusivity and promote diverse perspectives in technological development. Moreover, involving indigenous communities can lead to culturally relevant approaches in space exploration, especially in areas like environmental stewardship and ethical considerations in technology development. 9. Challenges and risks. While the report outlines the milestones in funding, it could place greater emphasis on the inherent risks and challenges associated with these ambitious goals. Technical failures, budget overruns, and regulatory hurdles are common in space exploration. And a candid discussion about these challenges can provide a more balanced view of the Starship program's trajectory. 10. Long-term vision for humanity in space. The report sets out immediate milestones but does not sufficiently address the long-term vision for humanity's presence in space. Discussions about sustainable human life on Mars or the Moon, the ethical implications of colonization, and the potential for human civilization to become a multiplanetary species are critical topics that could inspire deeper engagement and investment in the space sector. Conclusion. In summary, while the report outlines significant milestones in funding allocations for SpaceX's Starship program, it is essential to recognize the broader implications of these developments. By emphasizing international collaboration, the economic impact of funding, sustainability, human factors, technological transfer, global policy influence, public engagement, indigenous participation challenges, and a long-term vision for humanity in space, a more comprehensive understanding of SpaceX's role in shaping the future of space exploration emerges. These elements are crucial for painting a complete picture of the transformative potential of interplanetary missions and ensuring that stakeholders are aligned with the overarching goals of sustainable and ethical space exploration. 1. First crewed flight in human space exploration. The successful execution of SpaceX's first crewed flight of the Starship is a pivotal milestone that holds significant implications for human space exploration. This mission will enable astronauts to experience Starship's capabilities in real time, providing invaluable data for future missions. This milestone underscores SpaceX's commitment to advancing human presence in space, particularly in preparation for long-duration missions to the Moon and Mars. The success of this mission will not only enhance public confidence in commercial space travel but also shape the future of interplanetary exploration by establishing a reliable platform for human crews. 2. Lunar missions and international collaboration. SpaceX's role in NASA's Artemis program, particularly through the Starship's involvement in lunar missions, marks a critical step towards sustainable lunar exploration. The integration of Starship into the Gateway initiative and its capability to transport astronauts to the Moon's surface highlight the importance of international collaboration in space exploration. The partnership with the Canadian Space Agency (CSA) and other international entities showcases a unified effort to expand human exploration beyond Earth. This collaborative approach is essential in pooling resources, expertise, and technological advancements, which are crucial for the success of upcoming lunar missions and the establishment of a sustainable human presence on the Moon. 3. Mars preparations and sustainability focus. The design and testing phases of Starship are specifically tailored towards future missions to Mars, emphasizing reusability and sustainability. This focus on developing a sustainable interplanetary travel system is instrumental in addressing the challenges of long-duration human spaceflight, including life support systems, in situ resource utilization, and environmental impacts. The ability to reuse spacecraft significantly reduces costs and enhances mission viability, aligning with the broader goals of sustainable space exploration. As SpaceX prepares for Mars missions, the technological advancements achieved through the Starship program will likely influence the future of space travel, making it more accessible and environmentally responsible. For funding allocation and economic impact, the allocation of $3.2 billion towards the Starship program reflects a strategic investment in advancing interplanetary missions. This funding not only supports the critical milestones outlined in the Starship integration plan but also facilitates collaboration with international space agencies, enhancing global efforts in space exploration. The economic implications of this investment are significant, as it is expected to stimulate growth within the space sector, create job opportunities, and foster innovation. The focus on integrating advanced technologies and promoting partnerships within the space industry will ultimately contribute to a more robust and competitive global space economy, positioning SpaceX and its partners at the forefront of future space endeavors. 1. Apollo Program 1961–1972. NASA's Apollo program aimed to land humans on the Moon and return them safely to Earth. The program achieved significant milestones, including the first crewed moon landing, Apollo 11, in 1969, which involved extensive planning, technological development, and international collaboration. The program ultimately included 17 missions with 6 successful lunar landings. Apollo's success was marked by its substantial funding, which was pivotal in achieving its ambitious goals, similar to SpaceX's current funding allocation for its interplanetary missions. 2. Mars Exploration Rover Missions 2003–2018. NASA's Mars Exploration Rover missions, including Spirit and Opportunity, significantly advanced our understanding of Mars. These rovers were designed to explore the Martian surface, analyze soil and rock samples, and search for evidence of past water. The missions faced numerous technical challenges but ultimately provided crucial data that informed future Mars exploration strategies, paralleling the challenges and milestones SpaceX faces in preparing Starship for Mars missions. 3. International Space Station 1998–present. The International Space Station (ISS) is a collaborative project involving multiple countries and space agencies, including NASA, Roscosmos, ESA, JAXA, and CSA. The ISS serves as a microgravity research laboratory and has facilitated numerous scientific advancements and international cooperation in space exploration. The collaborative nature of the ISS mirrors SpaceX's partnerships with international agencies like the Canadian Space Agency for its lunar and interplanetary missions, emphasizing shared goals in advancing human presence in space. Future outlook: integration of SpaceX's Starship and interplanetary missions. In 2024, SpaceX is poised to make significant advancements with its Starship program, reinforced by a $3.2 billion funding allocation aimed at interplanetary missions. This initiative is pivotal for the future of space exploration, particularly in preparing for human presence on the Moon and Mars. Below are 5 critical milestones anticipated for the integration of Starship, along with insights into the future of space exploration. 1. First crewed flight of Starship. One of the most anticipated milestones is the first crewed flight of Starship. This mission is designed to test the spacecraft's capabilities with astronauts on board, marking a pivotal moment in human space exploration. Successful completion of this flight will not only validate SpaceX's design but also provide invaluable data on crew safety and performance in a space environment. As SpaceX prepares for longer duration missions, the insights gained will be crucial for future interplanetary travel. 2. Lunar missions and the Artemis program. SpaceX's involvement in NASA's Artemis program, particularly in lunar landings, will be a game changer. Starship is expected to play a key role in transporting astronauts to the Moon's surface, aligning with the Gateway initiative. This collaboration will foster deeper exploration of the lunar surface, support scientific research, and test technologies needed for future Mars missions. The success of these missions will serve as a foundation for establishing a sustainable human presence on the Moon, which is essential before venturing farther into the solar system. 3. Preparations for Mars missions. With Mars being the ultimate goal for SpaceX, 2024 will see intensified efforts in preparing Starship for interplanetary missions. The focus will be on enhancing the spacecraft's reusability and sustainability, crucial for the long-duration travel that Mars missions will require. This includes refining life support systems, radiation protection, and creating protocols for landing and returning from Mars. A successful demonstration of these capabilities is expected to bolster support for human missions to Mars slated for the late 2020s or early 2030s. 4. A satellite deployment and global connectivity. In addition to crewed missions, Starship will enhance SpaceX's capacity for deploying large satellite constellations, which is integral to the Starlink project. This will significantly improve global internet access and facilitate communication for remote regions. The ability to launch multiple satellites at once will not only streamline operations but also enhance SpaceX's market position in the rapidly growing satellite internet sector. As a result, the successful deployment of these satellites will generate revenue funding further exploration endeavors. 5. Ongoing research and development. To ensure that Starship meets the rigorous demands of space travel, continuous research and development will be critical. This encompasses advancements in propulsion technology, materials science, and safety protocols. Collaborations with international space agencies, including the Canadian Space Agency (CSA), will be instrumental in sharing knowledge and technology, making space exploration more efficient and inclusive. The collective effort will focus on addressing challenges like environmental impacts and the sustainability of space technologies. Funding allocation and collaborative efforts. The $3.2 billion funding allocated for the Starship program underscores the commitment to advancing space exploration. This investment will not only cover the milestones mentioned but also foster partnerships with international space agencies. These collaborations, particularly in lunar exploration through initiatives like the Gateway Space Station, will facilitate the sharing of expertise and resources, ultimately leading to more successful missions. Common themes and perspectives. Across various sources, there is a shared emphasis on the sustainability and reusability of space technology, which aligns with global efforts to make space exploration environmentally responsible. Furthermore, the importance of international collaboration is frequently highlighted, showcasing a united front in tackling the challenges of deep space exploration. However, perspectives on the timelines for specific milestones vary, reflecting optimism and caution within the space exploration community. While some experts predict accelerated timelines due to advancements in technology, others urge a more measured approach, considering the complexities of human spaceflight. Conclusion. The integration of SpaceX's Starship in 2024 represents a pivotal moment in the evolution of space exploration. As the world watches, the successful achievement of these 5 critical milestones will not only pave the way for future lunar and Mars missions but will also redefine humanity's capabilities in exploring the cosmos. The collaborative efforts, substantial funding, and commitment to sustainable practices will ensure that space exploration remains a shared endeavor, fostering innovation and discovery for generations to come.